Hi, today's topic is histograms, and we are going to stick with our theme of learning to make univariate graphs both by hand and using technology. Today we are going to discuss making histograms by hand and also making histograms using a graphing calculator. These first couple slides are not necessarily in your printed or written notes that you have, so I just want you to look at this with me. The histogram is an example of a graph that maybe you haven't heard of by name before, whereas when we talked about the pie chart and the bar graph, I assumed that you'd seen those in your day-to-day life previously. A histogram is a graph that can look like a bar graph, like you just look at it like, this is a bar graph. But if you compare and contrast it with a bar graph, maybe you will see why it is a little different. It is the same in that it has bars. Great. However, if you take a look at the labels on the axes, this points out the difference. So this axis looks pretty much the same as what you would expect on a bar graph. It's a count, right? So frequency of test scores, that's like how many test scores. That is a way to set up a bar graph. A bar graph might have counts. It might have what we call relative frequency, which is when it has percentages. But if you look at the other axis, this is very different than the example we had the other day with people's opinions about the NFL. This is a numerical scale as well. So in a histogram, both axes have a numerical scale. And if you look and think about it a little bit harder, then you might say, okay, well, what is this bar then? This bar is 1 unit tall, one entity, one person, one element of this data set was what? Like, how would you finish that thought? Well, it looks here like this is a numerical scale, right? And that maybe is counting by twos, 52, 54, 56, 58, 60. So this would be 50, 2, 4, 6, 7. So it looks like there is one element that is somewhere between 50 and 57. So the data that was needed to make this display had to be numerical, had to be numbers. So this is different from a bar graph. Remember, a bar graph is for categorical data. A histogram is used when you have quantitative data. That makes it a very different kind of graph. Similar in having bars, different otherwise. Okay, this graph and set of questions is just to practice reading a histogram. So this histogram shows the height in centimeters of a group of 30 people. And so there's some questions here. How many people have heights between 159.5 and 169.5? So I'm going to find that on my scale here. And then I read up. Oh, 7. How many people have heights less than 159.5? That would be this direction. So that would be 6 plus 9 or 15. How many people have heights more than 169.5? 169.5 is right here. So more than that would be this bar of 5, 6, 7, 8 people. And what percentage of people have heights between 149.5? 149.5 is right here, and 179.5 is right here. So that's 9 plus 7 plus 5. So that's 21 out of 30. Also known as 0.7, also known as 70%. Okay, so I should include this just so you can get your bearings on what a histogram is like, how you read it, and also to demonstrate to you this is the kind of assessment question that you could have, right? I certainly could ask you to create a histogram, but I also could ask you to read a histogram. Now, in your official notes, you see that I wrote to you a histogram is a quote-unquote bar graph, and I put the quotes there because it's made with bars, but it's not the same as a bar graph. It's going to take a list of numbers, quantitative data. It's going to divide it into equally spaced groups and then show the frequency or how many elements of the data set fall into that group. Now, this set of rules is what we would call a rule of thumb. Now, a rule of thumb is something that would just be like generally true, sometimes useful. There are times when if you apply this set of rules, your histogram doesn't look that great. You still have to think, right? Like when you get to the end and say, do I like how that looks? And if you don't, you adjust, okay? So like a rule of thumb might be like if you're making some spaghetti sauce, they might say, the rule of thumb, put in this much oregano, put in a teaspoon of oregano. But maybe your family loves oregano, and so that rule of thumb, you're going to adjust and say, oh, my family loves oregano, so I'm going to put in a lot more than a teaspoon, right? So that's what I mean. Like this is something that's kind of like a foundation to begin from, and then you adjust depending on your data set. So you see that the rule of thumb says we're going to count up how many pieces of information we have. We'll take the square root of that number, and then we'll round it up. That result is how many classes you need. So what I mean by a class, it's like how many intervals you have. So in this particular graph, we have 1, 2, 3, 4, 5, 6. We have 6 classes or 6 spaces from which the bars go up, okay? So how many like chunks you're going to have. Then you find the range. The range is where you take the highest value and subtract the lowest value. And you're going to divide it by how many bars you have, and then that's what you count by, right? You can count by 2s, you can count by 5s, you can count by 7s, right? So whatever number that is, you're going to count by that number, and then those will be your brackets, so to speak. Okay, so to demonstrate that set of steps, I have this example. This is not real data. This was just me making up numbers, okay? So let's say that we had 30 high school seniors and we knew how much all of them weighed, okay? So like we had them step on a scale or tell us how much they weighed in pounds. So the rule of thumb starts out with how many pieces of information are there? There are 30. We're going to take the square root of that and round up. Then, so I'll let you do that on your own. And we're going to determine the range. The range is the highest number minus the lowest number. Those are the max and the min. So subtract those to find the range. And then you're going to take that number and divide by the previous one. Round it up. Okay, so you round this to the next highest whole number. Then you're going to take 160 and divide by that, and then that is what you're going to be counting by. So I invite you to just pause the video here and finish these computations. Come back when you're done. All right, so you should have this. There were 30 pieces of information. When I take that square root, I get 5.477 something, okay? So I am going to round that up. Even if it had been 5.1, I would still round it up. That is what this rule says, okay? You always go up. You always go more. Otherwise, you might end up with data points that are outside of what you label as your last interval, right? You need the intervals to be wide enough that that last class captures the highest data point. Okay, so that's what you're accomplishing with the rounding up. So we will round 5 up to 6, set that aside, then take our range, which was 160, divide our range, 160, by how many classes we needed. So I'm dividing 160 by 6 right here, and I get a decimal there as well. And again, I'm going to round up, again, to capture all the data. And so I'm counting by 27s. This is a super weird number to count by, but it is possible. You can do it. I have faith in you. So you're going to start with your lowest value, which is 100, and then add 27. So that's 127. Then you're going to take the 127 that's here. Whoops, that is not a good number color to highlight with, sorry. So take the 127 and repeat it here. And then add 27, that's 154. Take the 154 and repeat it into the next interval, and that's 187. So it's like, you know, if you ever say to someone, pick a number between 1 and 10, 1 to 10 is like a bracket. That's what we're doing here. We're making these brackets So like 1 to 127, then 127 to 154, etc. Okay? Now you might notice that the way I wrote this, I have some squared off brackets and some round brackets. The point of that is to make sure that numbers that are on the edges of the brackets, like make sure that it's clear which one includes that value. So for instance, 208 is included in this bracket. 208 is not included in this bracket. So if there were a data point that was 207.9, it would be in the bracket of that has the 208 highlighted in yellow. Okay, so 207.9 would be here, 208 would be here. Okay, and then you might notice I've worked ahead a little bit. And what I did is I went through and I tallied. Now this part of the process is a pain, absolutely a pain, but it is not hard. Okay, so for instance, 192. I would cross that off. I'd say, oh, 192, you're in this bracket, and I'd make a tally mark. 152, 152, you are in this interval. I'd make a tally mark, okay? Now, I've already done that ahead just to save us time, right? And so you tally up your frequencies like this. Now, from that, you should be able to make a nice histogram. So on the bottom, you're going to write out what your classes were. Okay, where am I getting these numbers from? These exact numbers are right in here, right? What I figured out counting by 27. So 100, 127, 154, 181. Those same numbers are going to be what I use across here. This is in pounds, right? This is weights of people. Up on this axis, this is going to be my frequency axis. And I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8. I think the most I had was 8. Okay, so each of my tick marks there is just equaling 1. And then when I make my bars, I'm going to come up from these edges. The bars are going to exist across these spaces, and they're going to be right up against each other. Okay, remember how that looked in the beginning in that example that we had? Right, how these bars were like right up against each other? That's important. The only time that you're going to have a space in a histogram is like here. There wasn't any data in this example. No one scored on the test between 57 and 64. No one. Right? And so this space is representing a bar of height 0. No data was in there. That is the only time you're going to have a space in a histogram, is if you actually have an interval that does not contain any data. Otherwise, all the bars are like right up against each other. Okay, so please finish labeling this axis and use the tallies that I have here, the 8, 5, 7, 7, 2, 1. Use that frequency information to finish out the histogram. Okay, please draw it yourself before you look ahead at what mine looks like. Okay, that's the only way to know if you get it. Okay, go ahead and pause the video and finish your picture. Okay, so here is my kind of poorly drawn picture, but this is the gist, okay? You have your weights across the bottom axis. You have your frequencies going up this way. Something I forgot to mention before I had you pause is this little lightning bolt. That is a nice thing to include anytime your axis does not start counting at 0. So to signify to the reader of your graph that, hey, I am jumping here, I am not starting from 0, it is nice to kind of denote that to make sure that your reader catches it. Okay, that's what your histogram should look like. All right, the last thing that we have to do today is to take a look at the calculator. So here is some actual data. I looked this up years ago, so I don't know how much it has changed since I looked this up. But at the time that I looked it up, this was some data about 9th graders, 14-year-olds, who had used marijuana. So different countries and what percentage of ninth graders according to survey data. So again, a little bit cautious because you never know if people are reporting accurately. But according to survey data, what percent of ninth graders claimed that they had indeed tried marijuana? So what I'd like you to do is to have your calculator, and you're going to enter this data. Now, something that sometimes causes problems is that people will look at a table like this and they will say, oh, here's list 1, here's list 2, here's list 3, and that is wrong. Do you know why? How many variables are represented here? Just the one. The one variable is what percent of ninth graders have tried marijuana according to survey data. That is one thing, right? It's not like this column was marijuana and this column was something else and this column was something else, right? That is not what we're looking at here. It's all one variable. So it is presented in multiple columns on the piece of paper just to save space, okay? It all goes into list 1 on your calculator. So to remind you, we are going to go into Stat and into Edit, and then you're going to type all the numbers that you saw in that data set all into list 1. So I will go back to that. You can pause the video if you need to look at this for a while in order to type it into your calculator. Okay, so here we are picking up from having your data in. So once your data is in to see a histogram, it's going to be a lot like the box and whisker plot the other day. So I did second and y equals, go into stat plot, going to select that. I'm on, and I also want to be on the histogram picture, which is this guy. Okay. Then once I'm on my histogram picture, and I should have made sure first of all also that there was no other junk in my y equals, right? If there's something else there, your calculator might freak out because you're asking it to do multiple things at once. Okay, and then I'm going to use the zoom statistics, which is option number 9. And the little elves in the calculator are going to pick what they think I should count by. So as I hit trace, you can see at the bottom of the screen, this is telling me this first bar is 9 units tall, and the number that is on this edge would be 2, and the number here on this edge would be 12.2. And maybe I don't like that. Maybe I don't like counting by a decimal, right? So the elves in the calculator picked what they think I'm going to like, but maybe I don't like it, right? It is entirely possible that that is the case. Right, so as I trace through here, right, if I click on trace, or actually I think I just hit arrow. Yeah, I just hit the right arrow. As I go left to right, you see the cursor move and it's telling me the edges, and maybe I don't like those decimal values. Maybe I do. If I do, then I'm fine, right? I can just go through my graph and take the information from here and put it onto my piece of paper if I need a piece of paper kind of graph, okay? But if I don't like it, what I'm going to do is override. So if you go into the window, you can see that right here, X scale is what you're counting by, what you're scaling by on the x-axis. And maybe I don't like it as counting by 10.2. Maybe I want to count by a flat 10. And maybe instead of counting starting from 2, I want to count from 0 and go up to 70. Where am I getting these numbers? From my own brain, right? I am just picking numbers that I think I would like better. And then don't do zoom stat again. That will just take you in a big old circle and make that 10.2 again. But if you now go to graph, you can see the look of the graph is different. It's because the grouping of the data is different. And if I hit trace now, it's saying, okay, between 0 and 10, that's 6 units. There's 6 countries that fit in that bracket. And between 10 and 20, there's 7, right? So it did change the look of the graph. Maybe I don't like this look. Maybe I do, okay? But I do like these numbers being like rounder numbers. I think that's kind of nice. What if we changed it to count instead of by 10s to count by 5s? Let's look at that. Oh, well, that's really chopped up now, right? putting it into increments of 5, there's a lot of data out here that's just all separated. I don't think I really like that, okay? So there's sort of a sweet spot, right? If I put, for instance, if I were to put this as 70, it's going to be a ridiculous graph because it's one big bar. It goes off the screen actually, right? It's just one big rectangle. It goes like way up here. That's ludicrous, right? And you might think that counting by fives also is kind of ludicrous. So maybe that's kind of like not helpful, right? In terms of understanding data. So maybe there's a sweet spot, right? Maybe somewhere like 8, 9, 10, right? The calculator thought 10.2 was good. But you can kind of play around with this, right? Like this is something that I would look at if I were doing a report where I had a histogram. I might say, okay, how is it the best representation of data, right? There might be kind of a sweet spot that would help me understand the data well and also not be awkward, right? Usually like decimals are a little more awkward than whole numbers for most people, right? I kind of liked this 10. I think this was pretty good. That might be what I would use, okay? But you're certainly welcome to use the default, right? ZoomStat is going to give you something. If you like it, go with it. If you don't like it, overwrite it by going into Window, all right? So that's how you make a histogram on your calculator. You also know how to make the histogram by hand using the rule of thumb measurements, okay? Thanks so much.